Hi, in this video we are going to be talking about how to find the horizontal asymptote of a rational function. Okay, so where are we? So let's go straight to fun problem. So it says find the horizontal asymptote. Well, question is, how do we find it? So we have two case scenarios. So case one, it says if the degree of the numerator and denominator are the same, then we'll handle it some way. But case 2, if the degree of the numerator is less than the degree of the denominator, then I guess I should keep on reading. Okay, so the moral of the story is this. To find the horizontal asymptote, we are going to base it by looking strictly at the degrees of both the numerator and the denominator of the rational function. So the degree of a polynomial is just code for the highest or biggest exponent on any of the variable terms. So the degree of the numerator, I'm like, okay, the degree of what is the highest exponent? The biggest exponent is 2. The degree of the denominator, what is the biggest exponent? It's, in this case, is 2. So then the question that I'm going to ask myself is this: are the degrees are the same? Is the degree of the top less than the degree of the denominator? But in this case, as you can see, the degrees are the same. So the question is, well, what is the horizontal asymptote? If the degree of the numerator and denominator are the same, then the horizontal asymptote is given by the quotient of the leading coefficients. So in this case, let me just go ahead and write down the notation or made up abbreviation for horizontal asymptote. The horizontal asymptote will be given by the quotient of the leading coefficients. So horizontal asymptote, it's a horizontal line, and equations of horizontal lines are of the form y equals some number. The horizontal asymptote will be given by the quotient of the leading coefficient. Leading coefficient of the numerator is 3. The leading coefficient of the denominator, let me go ahead and use my special effect 1. Leading coefficient of the denominator is 1, and last time I checked, quotient of 3 and 1 is 3. So the moral of this story is that the horizontal asymptote is given by y equals 3. Let's go ahead and look at our second fun problem. So we are asked to find the horizontal asymptote. So again, to answer that question, we base our answer by looking at the degrees of the numerator and denominator. The degree of the numerator, what is the biggest exponent on any of the variable terms? I don't see a variable term, so I'm going to skip it. Let's go ahead and look at the degree of the denominator. The degree of the denominator is 2, because that is the biggest exponent on any of the variable terms. But now it's time to face my fears. So we don't have a variable term. So you have options. Either one, you either remember that the degree of a constant is 0, or 2, we're going to go ahead pencil in a fake x. So we're going to write 1 as 1 times x, which I know you know is not correct because 1 is not the same as 1x. But we are going to write x in a very nice way. We're going to write x as x to the 0 power. So gentle reminder, the 0 exponent rule says that x to the 0 power is 1. So we're pretty much writing it as 1 times 1 over 1. So with that being said, what is the degree of the numerator? The degree of a polynomial is code for the biggest exponent on any of the variable terms. So thanks to our fake variable, the exponent is 0, so the degree of 0. So now the question of the hour is, are the degrees the same? And the answer is no. But we notice that the degree of the numerator is less than the degree of the denominator. And if that is the case, if the degree of the top is less than the degree of the bottom, then the horizontal asymptote is given by y equals 0. So there's no division. If the degree of the top is less than the degree of the bottom, there's no way around it. The horizontal asymptote, the equation is given by y equals 0. That's my time. Thank you.